So 6 years before Kubernetes came onto the scene, when Google decided to open source their Bog system and us in the DevOps and cloud evangelists who saw this product saw that, hey, this solves a lot of problems for us. And immediately we went to our bosses and our CTOs and convinced them that this is the system we need to be on. And through trial and effort, as Kubernetes became more mature and popular, almost most companies these days tend to work on a containerized system or on Kubernetes, since that really allows us to scale if you have a stateless application. Stateful is slightly difficult on Kubernetes today, but it's still manageable. But coming back, so when we started pushing these products, there was one core group who was always left out in this. And they're the most important, I would feel, because all the technologies which come like Kubernetes, they're meant to serve one specific reason, is to keep our apps and to host them. And in that vein, the developers were always looped out. And most companies which I've seen, the ops tends to separate out from the dev team, and ops have their own procedures and rules compared to the dev team. And dev teams do not exactly know, okay, I've developed it, my CI runs, I pushed it. Now let's say in the Kubernetes world, the Docker containers in the registry. Beyond that, what happens? How is my application deployed onto Kubernetes? What are the steps which I need to interact with the ops team to get my services, like if I have a new application to onboard? And there's a lot of siloing, I would say, that between the ops team and the dev team. And this talk mainly jumps into how we can break down those silos and how we can empower our developers to use tools which closely resemble maybe a production Kubernetes cluster, so that when they develop, they have better ideas as to what they're actually deploying to. Because I'm a big proponent of not siloing knowledge. And as of today, the main deployment tool which developers use is Docker Compose, which is a great tool when Docker started out, because there wasn't really any other tool they could use to containerize applications. But Docker Compose was never built with Kubernetes in mind. Sure, you could use a tool like Compose, which converts Docker Compose files to Kubernetes, but you lose out a lot of features. Like you couldn't deploy operators. So if dev teams are informed that in production we have certain operators to automate tasks, like maybe pulling secrets or reloading pods, this is not something Docker Compose could ever do, and it's not even its focus. But how would the devs know this? And because of this lack of knowledge, they start baking features into the application which could be better pushed outside. So basically, the app should only have the core domain of the business rather than trying to incorporate features like maybe ingress routing, secrets management, restarting itself. These are, let's say, concerns which could be better served by another application. And this would be something the ops team will know, but not dev. And in the companies, generally, there tend to be friction between these two teams because of this lack of knowledge. And that was also something we noticed as SPIN quite a bit, because the developers never had context as to what we were doing. And ever since then, we wanted to break those silos. And as John had mentioned, the smallest team should do something. So from our DevOps team, we used to interact quite a bit with all the app teams to understand their requirements, how best do they develop, and how we could introduce new tools. And to do that, the first thing we need is, rather than spinning up a Kubernetes cluster in the cloud for them to work on, it can be quite expensive as a company grows and teams kind of diverge out, would be best to do it locally so that they don't interfere, or we can cut down on operational costs. So in this talk, I want to talk about three tools which can help developers achieve that. The first one being KinD, which is Kubernetes in Docker. Skaffold is a really nice build tool, and helm file is an optional thing. This is something we use, but you can use anything else. So in most companies, they tend to use helm or customize. So this is another tool like that, which is quite nifty. And later in the presentation, I'll show you what exactly it is. So first, coming to KinD, this is a really nifty tool which the Kubernetes SIGs team create. So SIGs is special interest group. So they're like a GitHub repository where you can see a lot of the projects which tend to promote Kubernetes or are built on Kubernetes, so that we can branch out in different fields and how better we can promote Kubernetes. So this is a tool which the team uses to test out new Kubernetes features. So since Git has really worked in a decentralized manner, not everyone from the Kubernetes developer group can spin up their own cluster and check out, hey, I want to test this new feature or PR I'm working on. For that, I would need to spend 15 to 20 minutes provisioning a cluster, testing it, and also incurs a huge bill if you're going to run, let's say, workloads which need a lot of nodes, or if you want to, let's say, simulate maybe control plane failures and so on. So instead of doing all that, we have nifty tools today like KinD, Minikube, K3D. So KinD is one of them, which I chose because since it's officially supported by the Kubernetes team, it's used in their CI pipelines, and a lot of projects like Helm use KinD for testing their own applications. This seemed like a really good fit for us compared to Minikube, because Minikube, when I used to test it, the boot up times tend to be really slow, but image load times are pretty good. So for us in the CI system, we want to have the smallest binary possible so that we can deploy things fast and test, have a rapid feedback cycle. So yeah, and KinD also has features like you can spin up a really production like Kubernetes cluster. You can have multiple control planes, n number of nodes, as long as the system supports. So that is, since it's a local thing, there's a lot quite heavy consideration in RAM and CPU, but that's beyond the scope of this. But it's something you can spin up your own Kubernetes cluster with the press of a button. So that's KinD. Then Skaffold is a really nice tool to deploy your stuff to the KinD cluster. So initially, when we pushed KinD to our developers, they had a hard time onboarding themselves onto using kubekettle to deploy their deployment configs, generating it. So that seemed more of a concern they shouldn't be dealing with, and also like pushing your image to the local Kubernetes cluster and then rolling it out. So all these seem more like yak sharing, where you don't really need to do it. And if a tool did it for us, all the better for it. So that one tool which Google again came up with. And I think they recommend this when you're using Cloud Run. So it integrates really well if you're on GCP with their, what do you call it, Git solution and Cloud Runners. Yeah. And also, though I wouldn't recommend it, it can be used as a CI/CD tool where you can build the image locally, push it to your registry, and then sync it to a Kubernetes cluster. So this would be great if your teams have a dedicated Kubernetes cluster and they can deploy to it directly rather than setting things up locally. So if that's how the company is organized, you can do it that way, but it works really well for the local setup as well. And I'll show all these tools at the demo section. We'll be getting there quite soon. And yeah, last but not least is Helm file. So another issue we had when we were pushing to our devs team using Helm charts is, to be honest, they're not the most easiest thing to work with, and Helm templating can be quite ugly. So we wanted a tool where the developers can at first glance understand what exactly is happening. So Helm file is like a declarative tool which you can list all the Helm charts in one file, and it just takes the values which you're passing to it. So they wouldn't need to go through all the YAML files for deployment, services, ingress, and the hundreds of objects which are available on Kubernetes. You can create the Helm chart and just expose to them, okay, these are the values, like this is the image tag which you're using, or this is a repository you're targeting. And Helm file also has a nifty tool. You can kind of consolidate all your environments using values files and the main Helm file. And you can template within the template. So you can template your values according to each environment, which we found really useful. So we can separate out our environments and the local testing so they don't clash with each other. And we tend to reduce the amount of times our deployment configs are being spread across various repositories, because duplication is the root of all evil in code and engineering. So the less we can duplicate stuff, all the better. And Helmfile really helps us maintain the same deployment scripts across our environments and local development. And let's get to the demo time. Let's hopefully demo gods are kind to me, nothing breaks. And let's see, we have the KinD config, which I spoke of. So here I've just set up a config where I have two control planes. So in your CI system, you want to do like chaos engineering. You could take a control plane down and still have another control plane to test, okay, is your application able to resiliently migrate itself to another node, or can it gracefully fail when everything else is failing around it? So KinD really, that's one really nifty tool which we have, though we don't use it today for any of our needs, but it's something you can do. So kind grows with you. And these are the growing pains which the Kubernetes team themselves had. So anything which you need to do on Kubernetes, I'm pretty sure you can do with kind, since it in with one command you can effectively run your own cluster. So if I bring up my terminal, this it's a really simple command to create a kind create cluster. You can pass in the config which is being passed here, but let me change the name to kind too, since I already have a kind cluster running. Oh, that's another thing. You can run multiple kind clusters on your system. So again, for operations team, this is great news, and we wouldn't have to constantly spin up a lot of Kubernetes clusters for each application workload. And there you go. It creates it for you. Now, I already have one running. So there you can use kubectl context. Just a second. Too many Z plugins. Cool. Thank you, ZSH autocomplete. So I have a pod running. Let's see. Yeah, there's a pod. And also, let's see, kubectl. Text kind get nodes. Since I think I spun out 3 workers, you should see these 3 workers here and 2 control plane nodes. And as these all are Docker images, if you do a Docker PS, there you go, kind nodes all over the place. So that's the kind config. You can configure this per team, whether you need to have multiple workers or not. I would recommend just using a single control plane, and none of these are needed. But for demo purpose, I just show that if you want to, it's possible. And also, this isn't the only things. You can also add stuff like if you have an external registry and you want to hook it to kind, you can declare a config here stating that, okay, this is the repository I want you to pull images from. Or if you want to enable feature gates on Kubernetes, like CSI, I think this was a year back when it was a feature gate. Now it's generally available, but feature gates is something which you can do. So we used to have like CSI plugins installed to test our, what do you call it? CSI plugins which we use on AWS. And then another one, Skaffold. So this is the declarative CI/CD solution. Here, I'm just using it to build the image and then push it to my kind cluster. And the really neat thing of Skaffold, which I didn't mention before, was that it monitors your repository. And anytime it notices a change, like perhaps the deployment configs changed or your app, maybe you updated main.go here, immediately it would rebuild the Docker image and push it to a kind cluster. So devs don't need to manually do all these setup, which are quite unnecessary to their development work. They just want to code stuff, immediately see it on their cluster. And Skaffold just does just that for us. And unfortunately, Helm file isn't supported by Skaffold at the moment. So I had to do a hack where I just generate the deployment config and then point Helm file, Skaffold to it. But if you're using Helm or Customize, it has first class support and you wouldn't need to do even these features. Anytime you change the file, immediately it will be rolled out. In my case, using Helm, I just need to create the deployment configs first, and then Skaffold will immediately pick it up. And last but not least, Helm. So this might look a bit intimidating at first glance, but it just defines various Helm charts. So here I'm defining the repository Helm chart. And another nifty feature which we recently discovered was Helm had introduced Docker image support for their Helm chart. So you can effectively package your Helm chart as a Docker image and push it to a Docker repository. So no longer would you need to host your own Helm chart application, and that reduces a lot of operational overhead for us. And it all keeps the artifacts so we don't accidentally delete it, shifting our concern away to the application rather than the uptime and disaster recovery for Docker images at least. So that's another nifty feature. So this is just the Helm file declaration. We have a chart which we use to define the application. So setting the deployment configs, security context, and pod. Now you might be wondering how are the values passed? So here I just state the repository and app. And this is something really important. So the image, what you define in your values file has to match Skaffold. So Skaffold, I've also defined it as such. So what it understands is that if it sees that repository defined in the deployment, immediately it can deploy to and keep changing the git sha tags. So right now I have an application running here. As you can see, Skaffold has just spun up. Let me clear this. Localhost. Ah, hello there. So simple hello world application in Go using web handlers. And then, yeah, it just echoes your name. So simple example, which I just picked it up from the Go tutorial page, nothing fancy here. And just the files value. So let me now update the file. So this part is the really cool or nifty feature. Let's see. App version 2. Immediately, Skaffold should pick up the changes. See, it noticed that a file is changed and started to rebuild. And this dirty tag here means that if you have uncommitted files, so you can see I have made a file change. So this is a good way if you have an external repository, these commits had uncommitted, these Docker images had uncommitted files. And also for developers, it would be easy to understand, is my image unmodified or have modifications been pushed to it? So yes, I can show the Docker file, nothing really fancy. We just build it and store it in an Alpine image. Going through the process, built it, and as you can see, it uses this tag and automatically updates the image tag. So we don't have to worry, okay, I need to set version 1.0 point something. Here, I've just defined it should use the git sha as the tag and is deploying it to the KinD cluster now. This is where I mentioned that Minikube might slightly be faster than KinD when it comes to loading images, because KinD uses it. It hits an architectural limitation of Docker where it needs to first unpack the Docker file into a tar file, load it onto KinD, and then make it a Docker image again. So until the Kubernetes team fixes that, there is this small issue, and you will run into it, especially if your workloads are on like Ruby or Python, because they tend to pull in a lot of packages with it. So images which are like 2.2 GB can take quite a while to get pushed. In Go, it's pretty nice because binaries can get compiled down to 20, 30 megs at max. That's really cool. So deployment was done, and you can see now. Let's see. Hopefully, it should show version 2. And there you go. This is app version 2. So that's pretty much it. And show the script. It's just simply this. We use helm file to define the Kubernetes YAML configs and Skaffold to point it to the Skaffold definition, and then the namespace where it should deploy to. That's -n here. And also, one of the nice things of Skaffold is that we can expose the ports. So this is one thing to keep in mind. If you have multiple applications running, you might need to figure out which port is assigned to which application. Unfortunately, this is an issue which stems from using Mac, since technically on Mac, to run Docker, you need to have a Linux container running in the background. So there's a lot of network translations which need to take place. So Skaffold takes care of that for us by just doing a kubectl port forward. So devs don't need to do it. There's also another tool called kubeforward, which you can use, but that's out of the scope here. That's if you have really complex application, lot of microservices in your local system, and you want to ensure that there are no port clashes. That kubeforward can kind of use a service name rather than exposing it directly to localhost. So yeah, that's pretty much it on demo.